Hi everyone. So for today we're going to go over Coulomb's law, and then we're going to go over an example of how to use Coulomb's law. Um, so Coulomb's law is the next step for our video series for the physics playlist. So Coulomb's law has to do with a repulsive or attractive force that is felt by two charges. So let's just say we have a charge here that's positive and a charge here that's negative. We know that there's going to be a force that's going to be felt by each charge individually, and F1 is going to be felt by charge Q1 and F2 is going to be felt by charge Q2. And we know that the magnitude of F1 is equal to the magnitude of F2. We also know similar things would happen if it's a positive charge here and a positive charge here. We're going to feel a repulsive force between these two charges. This is Q3, this is Q4, and we know that F3 is going to be equal to F4 in magnitude. So let me just write Coulomb's law down. So Coulomb's law is a force, an electric force, that's a vector. It's going to be equal to a constant K, which is known as the Coulomb's constant. Right here. Coulomb's constant times Q1 of the first charge multiplied by Q2 the second charge divided by the distance, which is R, which is the distance between the Q1 and Q2 squared. So Q1 is the charge of Q1, Q2 is charge of Q2, R is distance between Q1 and Q2. So, and one thing I forgot is when I wrote this equation down, we have to make sure a vector equals a vector. Right now it's a vector equals scalar. So there's a unit vector that is defined. It's a unit vector that's defined from a unit vector that starts from Q1 and points to Q2. So in this case, here, it's going to be defined this way. So let's get started with an example. Let's go over units. So a constant of Coulomb's constants has units of, this is one example of its units, newtons times meters squared over Coulomb squared. Charge of Q1 has units of coulombs. Charge 2 has units of coulombs, and R, distance between Q1 and Q2, in this particular case, if we're using Coulomb's constant with these units, is going to be meters. So let's dive in and get into an example. So let's say we have a charge, positive charge here, another positive charge here, and let's say this charge is let's just say 5 coulombs, and this charge here is let's just say 10 coulombs. Let's say the distance between these two charges is 50 meters. So if we apply this equation and convert it into a scalar form of this equation, we're going to get Fe is equal to Coulomb's constant times the charge of Q1 times the charge of Q2 divided by their distance between them squared. And if we plug in the numbers for this situation, Coulomb's constant, you can find this in a book, is 8.9876 times 10 to the 9th newtons times meters squared divided by coulombs squared. And we know that Q1 in this example is 5 coulombs. We know that Q2 in this example is 10 coulombs. And we know that the distance between them is 50 meters. So divide by 50 meters, and this, and then you square this quantity. So if you look here, this coulomb, these two coulomb units cancel with these two coulomb units. This meter square units cancel with this meter square unit, and then you're just left with newtons, which is the correct unit for force. So if we clean this up a little bit without all the units, 8.9876 times 10 to the 9th times 5 times 5 divided by 50 squared, and it's going to have units of newtons. So if we grab my calculator here, we can do this calculation. 8.9876 e to the 9th, or 10 to the 9th. I'm just 5 times 5 divided by 50 divided by 50. I'm just gonna put the answer in like 3 significant figures. It's gonna be 8.99 times 10 to the 1, 2, 3, 4, 5, 6, 7 newtons. So this right here is going to be the magnitude of the force that's felt by these two particles. Now we know that they're both positive, and from our previous video we know that that means they repulse each other. So this force, that's going to be, we're going to just call it F left is equal to Fe, which is, well, we got this number here, 8.99 times 10 to the 7 newtons, and we're going to have this force here felt on this this particle, or this particle. It's going to be headed in the opposite direction, and we're going to call it Fr, and it's going to also equal Fe. So that is the force that's felt by both of these charges in this situation. And if we define a x and y coordinate, if we define the positive x direction as this direction, we can see that FL is equal to, and let's just say this is the unit vector x is equal to FE times the unit vector x. But since this is heading in the opposite direction, we're going to put a negative here. And then same thing with FR. Well, not the same thing, but it's going to have the same magnitude. And based on the definition that we gave for x, the unit direction x, we know this is going to be positive here. So that's an example of using Coulomb's law, guys. I'll give you guys an example to do by yourself, and then let me know what you guys think, if you guys need help with the example, so you guys can have some practice. Let's say that we have a positive charge here, a negative charge here, and a positive charge here. We know in this situation, this negative charge here is going to be feeling an attractive force this way to this positive charge, and an attractive force this way to this positive charge. So my question to you guys is, at what point does these two charges, at what point, if I place this charge from like a certain distance and I bring it close to the middle, at what point if I get to some point, will the force of 1 equal force of 2? And so that would be like a good problem for you guys to find. And I'll just give you some numbers. I'm going to say this is 5 coulombs here, and I'm going to say this is 10 coulombs here. And I'll give you some more help. Let's define this as the x direction, yeah, so let's hopefully you guys can figure this problem out. So that's it and so if you guys can't, let me know in the comments below, and I'll go over this example. Yeah, so just to review what we did, we talked about Coulomb's law. We talked about its units. We talked about the vector form and the scalar form. We taught and gave an example using it. And so yeah, guys. So if you guys like this video, leave a subscribe to this channel and give this video a like. Yeah, and so that's it for this video. Take care, guys.